Hello, everybody. It's Mrs. Pound. I'm back with another chapter, Chapter 4 on atomic structure from BJU Chemistry 5th edition. The first section we're going to cover in Chapter 4 is on the early thoughts about matter. So our objectives for today are going to be to compare atomism and the continuous theory of matter, state the laws of definite proportion and multiple proportions, and to summarize the scientific evidence that led to the acceptance of atomism. Now, the ancient Greeks debated whether matter could be divided into small particles of matter. So this debate has been going on for a very long time. And two ancient philosophies about matter were one, the continuous theory of matter. This is that says that matter can be continuously subdivided without end, and this was supported by Aristotle. So, like these candy caramels in the picture, you could picture them being divided down and divided down and divided down and looking pretty much the same. And the Greeks said that this could go on without end, so infinitely. Um, to infinitesimally small pieces. And this was based on the Greek mathematical view of the world and the belief that all matter can be divided into two new wholes. Now, this idea held on for a very long time because of Aristotle, because he was so well respected at the time. That's why this was the dominant theory. However, there was also another theory called atomism, and this is that matter is made of separate, discrete particles. And one of the prominent Greek philosophers with this idea was Democritus. And he had this idea, and at the time, though, it was philosophical atomism because the Greeks did not experiment to discover things. It was all what you would call more thought experiments. They debated, they discussed, they thought things out. There was no physical experimentation going on with that to verify either of these ideas. And then atom, okay, for atomism would be the smallest particle capable of chemical interactions. Now, there was not a lot of more thought that went into this until more modern times when we started to experiment more physically with and performing scientific experiments. And it wasn't until the 17 to 1800s that really people started doubting what Aristotle said, his theory. So the first idea that went against that was the law of definite proportion, where it says every compound is formed of elements combined in specific ratios by mass that are unique for that compound. So this was the first idea that did not support what Aristotle said. And this was proposed by Joseph Proust in 1794. And experimentally, an example would be that any sample of water contains 8 grams of oxygen for every 1 gram of hydrogen. And at this time, it was based upon mass because still not much was known about what made up matter. Then John Dalton came on the scene. And he proposed the law of multiple proportions. This says that the masses of elements can be combined to form a particular ratio that can be reduced to small whole numbers. So, with the previous law, the law of definite proportion, this was based on masses. Okay, this was based on masses alone, where we see with the law of multiple proportions that these are small whole numbers. This is where we get our chemical formula subscripts from. When we put the numbers behind the element symbols, these are those small whole numbers for the most part. That's where this comes from. So this was a new development. So this idea of proportions. Dalton was the first to propose the first atomic model based on experimental evidence instead of just these thought experiments. And from his experiments, he determined that he believed atoms were like these billiard balls in the background, that they were just small circles, small, hard particles, very solid. Um, that's what the atom was. And so, what I want you to do is in this area by Dalton's name somewhere to draw a circle and label it as the atom because that's what the model of the atom was believed to be at the time. So he proposed four things. And the first was that all matter is made of atoms. So these particles. So he was agreeing with Democritus, not with Aristotle. The second statement he came up with that he discovered was that atoms are indivisible. They cannot be created or destroyed, was his second statement. His third was that the atoms of one element are different from the atoms of all other elements, especially their masses. So each element has a different mass. And the fourth thing he discovered was that atoms combine chemically in small whole number ratios. So this was the first atomic theory that was experimental. And as we'll see, it has changed. We have progressed, but it was a really good starting point because now people are starting to experiment. So our objectives for today's video were to compare atomism and the continuous theory of matter, state the laws of definite proportion and multiple proportions, and to summarize the scientific evidence that led to the acceptance of atomism. So don't forget your 5 questions, and I will be back with more about atomic structure.